So hello students, good afternoon and welcome to the physics class for class 8th. So first of all, I would like to tell you that whenever you join the classes, you should join with your name and then your school name and then the grade. So there are certain students who have joined with this particular nomenclature, but there are certain students who have not joined with this nomenclature. So uh, it is a request, please everyone, join with your name, school name, and your class, so that it is easy to find out which student has joined and from which school the student has joined, and we are able to connect with you better, and hence the delivery would be better. So please change your naming if you can, right? Otherwise, there would be someone who would assist you through chat how to change your name. So again, welcome to the session. So today, what we are going to do. So first of all, I'll introduce myself, though I have already done it in the orientation session, but students who have missed the orientation session, for them, I am Sunit Kumar, and I would be teaching you physics. So are you able to hear me properly? Am I audible to everyone clearly? Yeah, you can write on chat. Okay, thank you. So I am Sunit, and I'll be taking your physics classes during your summer course. And so we'll start with the first chapter of the physics, that is force and pressure. So, so students, so this is your chapter, force and pressure. So what are the prerequisites? So when I say prerequisite means what are things which you should already know, so that it becomes easy for you to understand. Though this is the first class, I would help you in understanding the concepts from the previous grades as well, so that you understand the concept well. So first prerequisite is basic mathematics should be known, addition, subtraction, multiplication. So whenever, we are adding forces, subtracting forces, so all of this concept is being used. So basic mathematics concept is first prerequisite. Second, you should know about distance. You should know about speed, right? So these are the basic prerequisites which is required for this class, so that you understand the concepts well. Now, let's talk about the weightage. So when I say weightage, it is about the annual exam weightage. For example, if you have an 80-mark exams, then 6 to 8 marks question comes from this particular chapter, that is force and pressure. So this is the weightage. When I say the range, because every school will have different approach in the annual exam. So out of 80, 6 to 8 marks is from force and pressure. So the questions would be from this chapter, force and pressure. Now let's talk about outline. What are we going to learn today in the class? So first is force. We'll understand what is force, basic definition of force. So, in the lower grades, for example, 7th class and 6th class, you have already studied that force is a push or pull. So this is the first thing which we'll be, discussing today in the class. Second is force is due to an interaction. So there should be an interaction between two bodies for the force to be applied on the other body, right? Or force to be applied on the first body with the second object. So there has to be an interaction between two objects for the force to be applied. Third is force has magnitude as well as direction. So today we'll understand what is magnitude, what is direction, and what are these quantities called, which has magnitude as well as direction. So this is what we are going to do in today's class. Fourth is, we'll explore forces. We'll get to know more about, the properties, the concept of force. We'll understand this in today's class. So let's start the class, students. So first of all, what is force? So if you see here, in this particular slide, you see that, a football is moving, right? So what does force does? First of all, a force, when it is applied on an object, it can help that object move, or it can help a moving body to come to a stop. So either it will move a stationary object, or it will help a moving body to stop whenever you apply a force, right? So why did the ball slow down? That is because of a force which we will study in your next chapter, the friction force. So because of the friction force, the ball comes to a stop. So the basic definition now. So force is a physical quantity that brings an object from rest to motion, or motion to rest. We'll keep on adding things to it. You will also see that force helps a moving body, to change the direction as well, right? So these are concepts which we'll keep on adding to this. So first is, force is a physical quantity that brings an object from rest to motion, or motion to rest. So if a body was at rest, if you apply force on that, it will start moving. And if a body was already moving, if you apply a force in opposite direction to the motion, the body will come to rest. So this is the basic concept of force. Now, what if there is no force? So if there was no force, for example, if there was no friction force in the previous case which we were discussing, the ball which was moving, it will keep on moving until and unless an external force is applied. So if there is no force acting, it will continue moving throughout. Okay, it will never come to stop. So object at rest will remain at rest. So if there is no force being applied, the object which was at rest, it will be at rest only. It will not move. And if the object was moving, it will keep on moving. It will not come to rest if there is no force being applied to this object. Now, we have, in previous grades also learned this or studied this, that force is a push or pull. So if we are standing, if this person, for example, in this slide, if you can see this man who is standing behind a car, so nothing happens. The car doesn't move until unless a force is being applied. So now when this person starts applying a force on the car, the car will start moving. So man applies a force in the form of push to make the car moving, right? Similarly, here in this case, if you see, a bull applies a force on the cart to pull it, and so that it moves. So if the bull was stationary, the cart would have been stationary. Now if the bull starts moving, it will start pulling the cart towards itself, and this again is a form of force. So force can be applied in the form of push in the previous case, and force can be applied in the form of pull, as you can see in this case, bullock cart case. So man applies a force in the form of push. Bullock cart, in the case of bullock cart, bull applies a force in the form of pull. So this gives us the basic definition of force. You students, you can write this down as well. So a force is a push or pull upon an object resulting from its interaction with another object. Okay, so there has to be two objects which needs to interact with each other for the force to be applied. So force is a push or pull upon an object, right, resulting from its interaction with another object. So this is your basic definition of force. So students, please write it down. So you should always sit with a notebook, a pen, so that you can write down important definitions, right? So that at the end of this summer course, you have your notes prepared, and then when you go back to school, you can use these notes to do well in your exams. Okay? So I'm sure that you have written this. You can just give a thumbs up if you have written it, so that I get to know that you are writing it. Very good. So now let's go ahead, student. So forces are used in our everyday action, whenever you push an object, whenever you are pulling an object, whenever you are lifting something, or whenever you are stretching something, whenever you are twisting something, or pressing something. So force are used in our everyday actions. So everyday actions like pushing, pulling, lifting, stretching, twisting, and pressing, all these activities leads to force, right? So force is used in all these activities. So all these activities which you do on a daily basis, you can see the force, you can observe the force being act. So let's go to the next slide, student. Now, as I said in the previous definition, in the previous slide, there was a definition. If you go and see that definition, a force is a push or pull upon an object resulting from its interaction with another object. So there has to be an interaction between two objects for the force to be applied. So that's why, let's go ahead and understand this a bit further, that force is due to an interaction. So you can see, as we said, that if there is no interaction, for example, when there is a car which is stationary and a man who is standing behind that, and he is also stationary and he is not interacting, he is neither pushing nor pulling, the car is not going to move because there is no force being acted upon. So for the force to act, this person will have to start pushing the car for the force to be applied on the car. And as a result, you will see that the car starts moving once the person starts pushing the car. So an interaction of one object with another object results in force between two objects. So if there has to be a force between two objects, there has to be an interaction between the object with the another object. So man applies a force in the form of push in this case. Now another uh, you know another example or definition, if we say, if both the objects are capable to applying force on each other, then the interaction between them can be of pushing or pulling. So let's say if both the objects are able to interact with each other, so interaction can be push or pull as well. So for example, I can push an object or I can pull that object. Both is possible whenever there is an interaction. So in this case, if you can see, these two students are trying to push each other. So in the in this figure, if you see, these two students are trying to push each other. So the student at the left is pushing towards the right, and student at the right is pushing towards the left. Similarly, in this second figure, if you see, in this figure, the man is trying to pull the cow or ox or bull, whatever you say. So, he's trying to pull this ox towards left, towards himself. So this is a example of pull. Okay. Now, at least two objects must interact for a force to come into play. As we saw that in the previous slide as well, there has to be two objects between which interaction has to be there. If if there is no other object and I'm trying to push, so I'm not pushing anywhere or any other object, so there will be no force which will be applied, right? Similarly, if I'm trying to pull in air, so there is nothing which I'm trying to pull. So there has to be an interaction between the two bodies for the force to be coming into play. An interaction of one object with another object results in the force between the two objects. So there has to be an interaction between one object and the other object for the force to come into play. Now, this is the basic concept of force, that it has magnitude as well as direction. What does this mean? So, for example, as we saw in the previous examples which we saw, so the man was pushing the car towards the left, right? So in that case, there is a direction to the force, right? He is pushing the car towards left. And let's say we give that magnitude also. Let's say he is pushing the car towards left with a magnitude of 10 newtons. So we all know that the unit of force is Newton. Okay. So when I say 10 Newton, 10 tells the magnitude, so the unit is being defined. And then when I say 10 Newton, it means, 10 times that 1 unit of Newton is being applied. So this is the magnitude. And when I say the direction as well, so when I say, let's say I am applying a force of 10 Newton towards north. So here the magnitude is 10 Newton and the direction is towards north. So magnitude and direction both is needed to define force. So all physical quantities which can be defined by magnitude as well as direction are called vector quantities. So this you are going to learn in your grade 9. There are two kinds of physical quantities. One is scalar quantity and the other is vector quantity. So scalar quantities are those which can be defined only by magnitude, which we don't need to give a direction to that. For example, distance is a scalar quantity, right? Similarly, you will see that speed is a scalar quantity. Work done is a scalar quantity. So these are all physical quantities which can be defined only by magnitude. So there are two kinds of quantities, as I said. So there are two kinds of physical quantities. So there are two kinds of physical quantities. One is scalar quantities and the other is vector quantities. So as I said, scalar has only magnitude and vector will have magnitude plus direction. Okay. So any physical quantity can be of two types. One is scalar quantity and other is vector quantities. Scalar quantities has only magnitude and vector quantities has magnitude as well as direction. Example of scalar quantity, as I said, you can see distance is one example. Speed is another example. So these are the two examples of scalar quantities. For vector quantities, same, displacement is a vector quantity. We'll see what displacement and distance is in further classes. And then force again is a vector quantity, as I was discussing, because to define a force, you have to define the magnitude as well as direction. Is it clear, student? Scalar and vector quantities, is it clear? Thank you, students. So the strength of a force is expressed by, yes, the make note this, this is very important. As in foundation, what we are going to do is we are going to study what is there in our syllabus of class 8, and we are also going to study something of class 9th, class 10th, so that the gap between these classes reduces and you are prepared for other competitive exams like Olympiad, and you are also prepared for your senior classes. When you go in class 9th, you already know this, so you will have a edge over other students, right? You will be better prepared than the other students. So please, if you want to write it, you can always write this. Whatever I'm writing on the slides, you can always take a note of that. So strength of a force is expressed by its magnitude. So, the magnitude will tell you the strength of the force, how much force you are applying. So SI unit of force, SI means International Standard Unit, right? So this SI unit of force is called Newton, and it is denoted by capital N. Okay. So again, you can see here the name Newton, though it is the name of the scientist, is written by a small letter. It is starting by a small letter, not by a capital letter, and that is purposefully done, right? So when you write the unit in full form, you are not using a short form, you will have to write, even if it is the name of a scientist, you will always write it with a small letter and not with a capital letter. So that is the that is the rule which we follow throughout in physics. So along with the magnitude of force, the direction in which force act is also to be specified. Because it is a vector quantity, since force is a vector quantity. So along with the magnitude, you also need to specify the direction. So when I say, 2 Newton of force would be an incomplete information. So you will have to write completely 2 Newtons towards north. Clear? Is it clear, students? Okay. So now let's move to the next slide. So if two forces applied to an object act in the same direction, then the resultant force acting on the object is equal to the sum of two forces. So let's say there are two forces which are acting on an object, right? So if two forces applied on an object act in the same direction, then the resultant force acting on the object is equal to the sum of two forces. What does this mean? So let's say we have an object, right? Okay. Can you hear me? Okay. So I'll again, repeat this thing which I was doing. So there are two, if there is on this object, on this block, there are two forces which are acting on this block. This is F1 and F2. Both are acting in the same direction. Then the resultant of the force which is acting here is F1 plus F2. Because it is acting in the same direction, we will add the two forces. So in this example also same thing is seen. If 5 Newton of force is being applied towards left and there is this 3 Newton of force applied towards left, both are in the same direction, and that's why we will add these two forces. Effective force is equal to addition of the forces, and that is going to be equal to 8 Newton. So we saw that here we had 5 Newton, here we had 3 Newton. Sum of this is equal to 8 Newton. Okay. Okay. Now, the same case, if the forces are acting in opposite direction, what is going to happen? So if the two forces applied on an object act in opposite direction, so then the net force acting on the object is equal to the difference between the two forces. So for example, let's say you have a block here and you are applying a force F1 towards left, and there is this force F2. So F1 towards right and F2 towards left. So here the resultant force, and if you have F1 is greater than F2, means the force which is acting towards right, if it is greater than the force acting towards left, in that case the resultant force will be equal to F1 minus F2. So this is your resultant force. So you will have to take a difference here. Why? Because the forces are acting in opposite direction. So if two forces applied on an object act in opposite directions, then the net force acting on the object is equal to the difference between the two forces. So forces acting in opposite direction, for example, let's say we are applying a 5 Newton of force towards left, towards right, and 2 Newton of force towards left. So the resultant will be the difference of that. So what will be the resultant? Yeah, I'll explain it again. So when I say, since let's say this is a block, okay, and on this block there are two forces acting. One is towards right F1 and other is towards left, that is equal to F2. So the resultant force would be equal to difference between them. Let's say I'm applying a force of 5 Newton from here and 2 Newton from here. So the resultant is going to be the difference between them, right? Is it clear? So for example, here, if you see here, there is a 5 Newton force which is acting towards right, and there is another 2 Newton of force which is acting towards left. So what is going to be the resultant? Resultant is going to be 5 minus 2, that is equal to 3 Newton. Clear? The student who asked the doubt, is it clear to you? Okay, thank you. Yeah. So resultant force is F1 minus F2 if it is in opposite direction. So in this case, because 5 Newton was acting towards right and 2 Newton was acting towards left, so resultant is 5 minus 2, that is equal to 3 Newton. So 5 Newton minus 2 Newton is going to give you 3 Newton. Clear, students? Okay, let's move. So effective force is equal to difference of forces when the forces are acting in opposite direction. And effective force is in a direction of larger force. For example, here in this case, 5 Newton was larger and 2 Newton was smaller. So 5 minus 2, 3 Newton, effective is 3 Newton towards right. But if, for example, here in this another example, let's say there is 8 Newton force which is acting towards left, and there is this 3 Newton force which is acting towards right, the resultant is going to be 8 Newton minus 3 Newton, which is equal to 5 Newton, and that will be towards left. Why? Because 8 Newton force is larger. So whichever force is larger, the resultant force will be in the same direction. Clear? Is it clear, student? Okay, so I'll rub this. Let's move to the next concept. And what happens, for example, if the two forces are equal in magnitude and opposite in direction? So if the two forces applied to an object are equal in magnitude and act in opposite direction, then the net force acting on the object is 0. So for example, let's say we have a block on which there is F force acting towards right and same force F is acting towards left. So the resultant force, as I said, because these are in opposite direction, this will be the difference of these two. So F minus F, this gets cancelled, will be equal to 0 Newton. For example, in a tug of war, let's say both the teams are equally strong. So when they pull that rope, so what will happen? The rope will not move in any direction. So this is the portion which is there on the line. So it will remain on the line only. It will not move towards right or towards left, and none of the team will win in this case. Clear, students? Okay. Now let's further understand every force in terms of action and whether that effort is leading to the force, and if the effort involved an interaction between two objects. So these are the descriptions on different situations. So for example, first thing, if you see, okay, so I'll explain it again. There is a student who had doubt in this. Okay, so for example, let's say we have this block. Now in this block, let's say there is a force 2 Newton acting towards right, and there is another force which is acting on this, that is 2 Newton towards left, right? Now, if you find the resultant here, what will be the resultant? 2 Newton minus 2 Newton, because these are in opposite directions. What will you do? You will take a difference of these two. So when you do this 2 Newton minus 2 Newton, so 2 minus 2 is equal to 0. So the resultant force is going to be 0 Newton. Is it clear, students? Vidhi? Okay. Okay. Let's move to the next. So here, what I was talking about is there are different situations. For example, drawing a bucket from a well, firing a bullet from a gun, moving a trolley. So in all of this, we have to first find out the action, the effort which leads to the force, whether effort leads to this force or not, and if the effort involved an interaction between two objects. So let's see. So first of all, drawing a bucket from a well, the action is pulling that bucket, right, out of the well. Now here, effort, does this effort leads to force? Yes, this effort leads to force. And is the effort involved uh, an interaction between two objects? Yes, there is an interaction. The girl is pulling that rope that is and which is connected to the bucket. So there is a interaction between the girl and the rope. Okay. Second case is firing a bullet from a gun, right? The action is firing of bullet. Now, effort leads to force. Yes, there is the effort. The bullet goes and strikes the wall, and there is a force which is applied. And is the effort involved in interaction between two objects? Yes, the wall and the bullet interacts with each other. Similarly, the trigger and the bullet, there is also again an interaction there. Now moving a trolley. So the action here is of pulling the trolley, right? And the effort leads to force, right? So here the effort is leading to force, and that's why he's able to move the trolley. And is the effort involves an interaction? Yes, this effort involves an interaction between that boy and the trolley, right? So this was a small exercise. Now let's do one question basically. So if you see this question, everyone please go through the question, right? And uh, then you have to answer it. So I'll just read out the question for you once. So the question is, in figure, two boys, A and B, are shown applying force on a block. So if the block moves towards the right, which one of the following statement is correct? So what is happening? The block is moving towards the right. Okay. First option is, option A says magnitude of force applied by A is greater than that of B. Second option is magnitude of force applied by A is smaller than that of B. Net force on the block is towards A. And fourth is magnitude of force applied by A is equal to that of B. So few of the students has already answered. Good. So you have been answering correct. So if you see, what is the catch here? The two boys A and B are shown applying a force and the block move towards right. When will the block move towards right? When the magnitude of force applied by A, if it is greater than applied by B, then only the block will move towards right. Okay. So option A is the correct option, right? Option B, someone has answered option B also. That will not be correct. Magnitude of force applied by A is smaller than that of B. If magnitude, yes, I'm sure, my dear friend. So when it is saying that magnitude of A is smaller, in that case, what will happen? It will not move towards right. It will move towards left because A is applying a smaller force. B is applying a larger force. B is towards right. A is towards left. So if I am applying a larger force, let's say A is applying a larger force, then only it will move towards right. Right? Here they are saying that A is smaller, the force applied by A is smaller than B. Okay? Is it clear? The student who has answered, Vidhi, you have answered option B. Is it clear to you? Why A is a larger force? Thank you. Let's go to the next now. So students, let's conclude what we have done today. So, the time is almost over. We have 3 more minutes to go. So let's conclude what we have done today. So first of all, we have studied a force, the definition of force. That is, a force is a push or pull whenever there is an interaction between two objects. Then we also saw that force is due to an interaction. There has to be an interaction. If I am not interacting with another object, that means I am not applying any force on that object. Third, what we studied today is force has magnitude as well as direction. So we saw that force is a vector quantity which has a magnitude as well as direction. Fourth is exploring more about forces. So we saw that when the forces are acting, on the same direction, we add the forces together. When the forces are acting in opposite direction, we subtract the forces. And when the forces are equal and opposite, then the force cancels each other effects and net force is equal to 0. So these are the three things which we studied today. Now, what is going to happen next? So when we meet next in physics class, we are going to study about effects of forces. So what are the effects of forces? You must be knowing some of the effects of forces. First effect is that, we started the class with those two effects. That force helps to move a stationary object when a force is applied. Second, when an object is already moving, force will, will try to stop that object if it is acting in opposite direction. So it can stop a moving object. It can move a object at rest. It can change the direction of an object. All of this is going to come in the next class, students. And then we'll also study types of forces. So there are two types of forces, contact forces and non-contact forces. So we'll study about that also in the next class. Okay. So before you leave, again, I'll reiterate that we'll be sharing with you your platform login credentials. So the school representatives, they'll get in touch with you. We'll take the email ID and passwords with you. We'll create your accounts, login accounts, and then you can, log into the platform. First Friday, we'll have a proficiency diagnostic test. Once that diagnostic test has been taken, we'll get to know your strengths, weaknesses, opportunities, and hurdles. And then, then what is going to happen is that once we know your strength, weaknesses, opportunities, and hurdles, we'll guide you to improve your opportunity areas, bring those opportunity areas to your strength areas, and help you, bridge those learning gaps. Okay. So next class, whenever we meet, we will go further and we'll study further. Okay. So thank you, students. Thanks for joining in. Keep on studying, keep on practicing, and let's meet in the next class. Thank you.